Okay, so today we are going to look at review problems for your exam. I was just mentioning to the class, and then I realized I should be recording this, that the questions could be phrased a little differently than that you might be used to when you're taking this, and that's really for me to try to minimize the temptation of cheating. And so certain things like you might be asked, instead of rationalizing the denominator, it might say, what would you need to multiply by to rationalize the denominator? And so we'll go over questions like that and review. And then if we have time, I'm going to start on 11.4, which gets into quadratic equations, which we were working with, but graphing them. Your test is on Wednesday. The test will be open from 12:01 a.m. to 11:59 p.m. on MyMathLab. And so what you want to do is you want to get into MyMathLab anytime that you have 2 hours to sit down and do the test. You are not supposed to leave the test while you start taking it. And you'll see a timer that will be displayed how much time you have left while you're taking it. While you're taking the test, you are writing it up just like you were writing up your homework solutions, and you want to, you're gonna be turning those in within, 15 minutes, uploading them in and turning them in on an assignment on Canvas. As well as that, the other part of the test is you're going to, the last question on your test, you're going to pull out your phone or something to record you, and you're going to record yourself explaining how to do that last problem. I'm having it so MyMathLab is scrambling the question order for every student, so your last question might be different than somebody else's last question. And so you'll get points for correctness on MyMathLab, and then you'll get points partial credit. So if you did something wrong on MyMathLab, but you did your steps right, I'll give you partial credit. If for some reason though you have an answer and you have no work shown, I might deduct points. So you want to be showing your work. Some of the questions are true and false. And so on a true-false question, I want you not just to answer true or false, I want you to show me why it's true. So work it out and show me that this side of the equation equals that side of the equation, or work it out and show me this side doesn't equal this side, and that's why it's false. So any questions on that before we start going through review questions? Okay. So let me start sharing my screen with you, and let's just start going through some problems. Okay, so we're gonna just start reviewing. Your test is on chapter 10 and chapter 11.1 through 11.3. So chapter 10 was on radicals. And chapter 11 was solving equations by different methods. And so let's look at okay, so how to work things around. So again, that certain apps wouldn't recognize how to do the question, and I can see that you guys are doing your own things. So for radicals, something that you might see is, let's say it says find the distance between the 2 points. And we're given that the first point is 0, and then that was the x value, and the y value is 2 square root of 3. That's the first point. Second point, the x value is -3 square root of 5. And the y value is 0. Okay, so you need to remember what the distance formula is. So if you have 2 points, and let's just do them arbitrarily, x sub 1, y sub 1, and x sub 2, y sub 2. We drove this distance formula. I don't know if you guys remember in class, but we did this by looking at these points arbitrarily on the graph and then using Pythagorean theorem to solve. Okay, so it was the change in your x value underneath the radical. So x sub 2 minus x sub 1, and that quantity squared, plus the change in your y value. So y sub 2 minus y sub 1, that quantity squared. So we have 2 points here. All we need to do is plug in our values. So we know what x sub 1 is, and x sub 2. And we know what our y sub 1 value is and our y sub 2 value is. So just go back and plug it in. So it's the change in our x value. So it doesn't really matter which way you go because you're squaring it. The only difference by changing the order is the sign here. So if we did, so -3 root 5 minus 0. And then that is squared plus the change in my y value. So 0 minus 2 root 3. I did it opposite on both cases. I should have done that the same way. Oh well. So here we have the square root. Well, that minus 0 is still -3 root 5. Quantity squared plus -2 root 3 quantity squared. Okay, so you need to remember how to square something. Notice that there's the number in front of the radical, but there's no plus or minus in between that -3 and the root 5. And so we're going to use the property of exponents there. So if you have something multiplied like that and you're raising it to a power, you're raising each piece to that power. And so I need to do that to my -3. So I'm squaring my -3 and I'm squaring my root 5. Plus I'm squaring my -2 here, same reasoning, and squaring my root 3. Well, -3 quantity squared is 9, all times root 5 squared, which is 5, plus -2 quantity squared is 4, all times root 3 squared is 3. So I'm just using order of operations by simplifying. So now we would multiply before we add. So 9 times 5 is 45, plus 4 times 3, which is 12. Before we can take the square root, we want to get this down to one number. So 45 plus 12, that gives me 57.
I'm not going to do it, girl. I'm just thinking about it. I'm not gonna...
No, that doesn't. Yeah, it does. Okay, so I'm trying to think, is 57 a prime number? It actually is not a prime number, but I don't think there's anything that I can pull out of it. The reason I know it's not a prime number, if I sum the digits 5 plus 7, that's 12. If you sum the digits of a number and that sum is divisible by 3, then that number has to be divisible by 3. So 5 plus 7 is 12. 12 is divisible by 3, so that tells me this is just with a trick with 3s. So 3 goes into there once, and 3 goes into 27 9 times. But 3 times 19, neither of those are factors that are perfect squares. So our distance is going to be root 57. So a lot is going on in this problem. It's showing me a lot that you know how to do, right? It's showing me you know the distance formula. It shows me here that you know how to square things with radicals in there, and you know the properties of exponents. It also shows me, you know, order of operations that you're doing when you're simplifying things down. And if possible, if this had something underneath the radical that had a perfect square, a factor of perfect square, that would also show me that you know how to simplify it that way. Any questions? Okay, so I don't have the chat screen up. So let me know. Chime in if you have any questions. So another example. So another way that I can test that you guys know how to work with radicals. I didn't mean to do that. Let's squeeze that. Let me get down. So what if you had a rectangle? I was trying to find some problem that I know that would work out good. Well, let's say one side is root 12 and let's say one side is 2 root 27. And it wanted you to find the perimeter of the rectangle. Okay, so perimeter, all that's telling you to do is we're trying to look at how the distance, summing all the sides of that rectangle. And so looking at the distance, so perimeter for a rectangle is your width plus your width plus your length plus your length. Or you've seen it as 2w, twice the width, plus twice the length. And so all we need to do now is go back in and plug in what the width and the length is. And so one is root 12 plus 2 times, and the other is 2 root 27. So we want to simplify this. We can't just sum this because there's not the same number underneath the radical. But I also noticed that there's numbers underneath the radical that are factors of those that are perfect squares. So let's just rewrite them real quick. So this is 2 times square root. Well, square root of 12 can be rewritten as 4 times 3 plus 2 times 2. So that is 4 times the square root of, well, 27 can be broken down as 9 times 3. So this is equal to 2 times square root of 4 is 2, root 3, plus 4 times square root of 9 is 3, and we're left with the root 3. So we have 4 root 3 plus 4 times 3, so 12 root 3. And so now that we have the same number underneath the radical, they're the same index, we can just add these together. So this would be equal to 16 root 3. Okay, so right there, that shows me that you know how to add and subtract or whatever terms with radicals and simplify. And then if it said B, find the area of the rectangle. Well, area is just length times width. So we have root 12 times 2 root 27. So I can multiply radicals. I can multiply the numbers underneath radicals if they're the same index and they're not both negative. And they're not both negative and we have the same index. The thing is, if I multiply 12 and 27 together, that's a huge number. It's easier for me to first break it down and pull out the factors right away that are perfect squares. And so maybe let's rewrite this. I'm going to pull my 2 out front. And then my square root of 12 again was 4 times 3. And the square root of 27 again was 9 times 3. So if I pull out square root of 4, which is 2, I'm going to pull out the square root of 9 and pull it out front, which is 3. And then underneath the radical, I have a root 3 for one and a root 3 for the other. So it's strictly multiplication. So 2 times 2 is 4 times 3. So right there, that is 12. And then square root of 3 times square root of 3. Well, that's square root of 9 or 3. So 12 times 3 gives us 36. Okay, so like I was explaining in the beginning of class, so here's a way I can test and make sure that you guys are doing things and certain features not pulling up and showing you step by step. So this is showing me that you know how to multiply radicals together and pull things out. So just make sure you know how to find the area and perimeter of a rectangle. You guys good with that? Okay. What about true or false? So some of these should be really, really fast. So looking at the following, true or false. So if we have the square root of 2 plus the square root of 2, this is equal to the square root of 4. Pulling up the chat. Anyone know? Is that true or false?
I mean, it's true and false, I guess, because it would be the square root of 4, but then you would square it and that would be equal to. Or no?
I say,
2 times 2 equals.
I say true.
You think it's true also? Anyone else out there?
Well, no, never mind. It's false because if you're adding and there's square, yeah, there's square roots, so you take them out with the radical.
Oh, no, it stays the same because you're adding them and not timesing them?
Okay.
Wait.
So there's a difference, right, between times and adding. And so we have root 2 plus root 2. Okay, so we're taking addition here, and it tells us we can add radicals only if it's the same number underneath the radical. So that's true, right? They both have the same number underneath the radical, and they both have to have the same index. So they're both square roots, so that follows the rule that I can add them. But what did we do when we added things together with radicals? So think of this as x. If I had x plus x, how many x's would you have?
So it's false because it's going to be to the square root, right? Or I mean, wow, to the second power.
Well, this is like 1 root x plus 1 root x. So 1 plus 1 is 2 root x, or root 2, sorry, root 2.
Good to know.
And so this was kind of a question mark. If I look at the square root of 4, what do I get back?
2. So it's actually
So this would be false. So on your exam, you're not just going to mark on my math lab true or false. You're going to explain on your paper why you got that it's true or why did you get that was false. What about same kind of deal, but this time true or false? And what if it was square root of 2 times the cubed root of 2 is equal to the 6th root of 2. So how can I show that's true or false? Okay, so first of all, we have a problem because we can't just multiply underneath the radical because rule said that the radicals have to have the same index. But there was a way that we went around that at the beginning of chapter 10. And the way that we went around that was we would rewrite these without the radicals. We would rewrite them with exponents. And so how could I rewrite the square root? That's the same thing as 2 to what power? So the index, which is not shown, is 2. That's my denominator. And this is raised to the power of 1. So that's my numerator. And this one would be, so the...
Was he nice?
What? Okay, so cubed root of 2. This is going to be 2 all raised to the 1/3 power. Okay, notice these are same base. What is the rule if you have the same base? What do we do when we're multiplying same base? What do you do with your exponents?
Going to add.
Yep, add the exponents. And so this would give me 2 raised to the 1/2 plus 1/3. I need a common denominator.
6.
So 2 and 3, common denominator is 6. So this would be 3 6 plus 1/3, that would be plus 2 6. So 2 6 plus 3 6, that's 5 6. If I rewrote that as a radical, my index is 6. So it's the 6th root of 2 raised to the 5th power. So was that the same thing that I got above, or it was asking true or false? Is that the same thing as the 6th root of 2? And so this would be false. So questions on those? What if it asked you rationalize the denominator? Of the radius r of a sphere surface A with a sphere with a surface area A. Where A is, where R is equal to the square root of A all over 12 pi.
So this is stuff we've already learned, but you're kind of showing us how we're going to take it on the test because you had to reword it.
So things have to kind of be reworded. So
Okay.
like we know how to rationalize a denominator. And so instead of just saying rationalize the denominator of this, it's saying, okay, well, this is a formula used for surface areas of a sphere, and this would be what the radius is. So basically ignore all this except for rationalize the denominator.
Okay.
And so here that tells me rationalize the denominator. That just means I need to get rid of the radical. In the denominator. And so rationalizing the denominator depended on, is there just one term in the denominator, or was there a sum of terms in there? Because if there was a sum, I would have to use the conjugate. We can use rules of radicals here. So we can break down a square root of a fraction as a square root of the numerator all over the square root of the square root of the denominator. So square root of A all over the square root of 12 pi. So I need to get rid of that radical in that denominator. And so I can pull out stuff now, or I can do it later. I noticed that root 12, remember square root of 12 has a factor. That's a perfect square. And so I know that this is the same thing as 4 times 3 times pi, or square root of a all over. So we can pull out the square root of 4, which is 2. And underneath the radical, we're left with a 3 pi. Okay, so look at the index, which is a square root. So that means we need, in order for the square root to fall away, we need enough things that they pull out. So we need at least 2 of everything, or a multiple of 2. And so I can't take the square root of 3. That's not a perfect square. But I know the square root of 9 is a perfect square. So if I multiply the bottom by root 3, and I know I need 2 pi's, I only have 1 pi there. We'd much rather have 2 pi's. And so this isn't, we started with well, it was an equation, but we're not squaring both sides. We are just doing the same thing to the one side. Get rid of that radical. And so this is equal to, so square root of a times square root of 3 pi. I can just rewrite that all underneath one radical. So this is the square root of a, or 3a pi. I don't know how you want to write it. All over 2 times, well, the square root of 3 pi times square root of 3 pi. So that's the square root of 9 pi squared. So we got the square root of 3a pi all over 2, but the square root of 9 we know is 3. So times 3, and square root of pi squared is pi. So this is equal to the square root of 3a pi all over 6 pi. Let me see if I can minimize this so you can see more of it together. Oops, too much. Does that help? So basically, if it had just said rationalize the denominator of that r equals, would have you had problems with that to begin with? Maybe. I was going to say, I think this is 10-4.
I think the pi just threw me off maybe because
I-
now that I see it, yeah.
The pi, yeah, pi is just that number. It's just a number. Don't let it mess you up. And it does, it scares people. Okay, so let's see what else I have on my list. So for another example, kind of the same idea. Let me blow this back up. So if it was 7 all over the 5th root of 25. And it's just asking what is needed to rationalize the denominator. So it's not asking you to do it, it's just asking you what is needed in order for you to rationalize the denominator.
So then the way that we would answer you would be in sentences?
So this in my math lab, I think it's going to have like a space where you would fill in what is missing, what were you going to have to multiply both the numerator denominator to get this denominator to fall away. So it's just kind of asking you the one step in here. And so let's look at the 5th root of 25. Let's break that down, because when we're trying to rationalize a denominator or numerator, we're trying to get rid of that radical. And so we need the number that is in our index, that number of things, or a multiple of that number of things underneath the radical for it to go away. And so if we rewrite 25, that's the same thing as 5 times 5. So I notice here I have 2 5s. And we have a 5th root. So we need how many 5s? 3 more 5s. Sorry, that doesn't look very well. Okay. So if I look at that, so 3 more 5s. So 5 times 5 times 5. So that would be 25 times 5, which is equal to 125. But I'm not just multiplying top and bottom by 125. I have to multiply top and bottom by what? Well, this index, right? It's the 5th root. So I need the 5th root. And then I need 3 5s left under there. So I need, the question is I would need the 5th root of 125 in order to rationalize this denominator. Okay, so let's just follow through on that and show that that's what we needed. So this won't be on there, but let's show what we found. Rationalizes the denominator. What do we have? So we had 7 5th root, 7 over the 5th root of 25. And we found that we wanted to multiply by the 5th root of 125. So we're not changing the problem by multiplying by 1 instead. So whatever we do to the denominator, we also have to do to the numerator. And so this is just equal to 7 times the 5th root of 125 all over, well, that's the same thing as the 5th root of 5 to the 5th power, which is just 5. Okay, so there's no more denominator or no more radical in the denominator. So another way that I found that works are looking at problems, and it says, look at the following problem. So look at the student's work of the problem and then figure out what is wrong with it. So find the error. So let's just do one of those and then we'll take a break. So what if we had the square root of 2x minus 1 plus 3 is equal to 5. And so the student went through the process to solve this. I don't like, well, maybe I don't like doing this because then I'm going to show you the process of what the student is saying to solve it, but it's not really the right way because there's an error in there. So let's take a break and I will write this out and then I'll post it. I'll share the screen so you guys can see if you can find the error. So let me pause the video. Maybe. Pause. Okay, so we're looking at a student who had done some work to solve the problem and we're trying to figure out what they did wrong. And so there's actually a couple of things that the student did wrong. They were correct in the fact that they were squaring both sides of the equation, and we can do that. And it looks like they wanted to do that because they were trying to get rid of the square root. But the first step, what you want to do when you're trying to solve an equation with a square root is isolate the square root on one side of the equation. If these had 2 square roots in here, I'm going to still do the same thing. I always want to isolate 1 square root on one side of the equation and get everything else to the other side. And so the first thing that students should have done was subtract 3 on both sides of the equation. So let me just rewrite the correct part over here. So the equation was square root of 2x minus 1, I'm doing the radical, plus 3 is equal to 5. And so first isolate the radical, we would subtract 3 on both sides. So we get the square root of 2x minus 1 is equal to, well, 5 minus 3 is 2. Okay, so now that the radical is isolated, now we can square both sides of the equation. So first thing they did wrong, they should have isolated the radical first. The other thing that they did wrong is when they squared both sides of this equation over here, they did that wrong also. Because notice when you are squaring, let me use a different color. This right here, this should have been the square root of 2x minus 1 plus 3, all times the square root of 2x minus 1 plus 3. And that does not equal what the person had put below. So if you FOILed that out or distributed, you would not get 2x minus 1 plus 3. Okay. So that was the other part where the student had gone wrong. Okay, so let's finish this problem. So you should isolate the radical first. We can get rid of the radical by raising both sides by the index, and this is a square root, so we're squaring both sides. And so squaring a square root, that cancels, and we're just left with 2x minus 1 on the left-hand side is equal to 2 squared, which is 4. So once you get rid of the radical, if there's any more radicals, you would repeat this step. But there's no more radicals, so there's nothing left I can do there. Then I would look at what type of equation I have, and I notice that this is a linear equation, so I want to isolate my variable on one side. And so in order to isolate my variable on one side of the equation, I would add 1 to both sides, and I would be left with 2x is equal to 4 plus 1 is 5. And then get x by itself, we could divide both sides by 2. And so we get x is equal to 5/2. But wait, I'm not done. Why not?
Does the 5/2 reduce? Never
I
mind.
could rewrite that as a mixed number, 2.5, but none of the fraction, nothing cancels with each other, so I could leave it like that.
Are you not done because you have to go back in and recheck it?
Yep.
Sweet.
Yay. So there's sometimes that we have to go back and check. Sometimes, I mean, if you have time, it's probably good to go back anyways, but this is a case where we might get an answer that doesn't work back in the original. And that was because we squared both sides of the equation. So if you raise both sides by an even power, you have to check it. And so we need to check. And so doing that, let me just move that down. So we have the square root of 2 times x. So I'm going to replace that with 5/2 minus 1. Is this really equal to? Actually, go back to the original equation. And so this was plus 3 outside of the radical is equal to 5. Okay, so replacing x with 5/2. So notice under that radical, 2 times 5/2. Well, properties of fractions, those 2's cancel. And so we're left with the square root of those 2 cancels. So we're left with 5 minus 1 under the radical. And then plus 3 outside of the radical. Is this equal to 5?
Yes, true.
Yeah, so square root of 5 minus 1. Sorry, trying to get this down there. Oh, well. This is square root of 4, which is 2. 2 plus 3 is 5. Where did my third thing go? I can't find where my first thing was that went wrong. So the third thing that went wrong for the student was they did not check. So third error, didn't check. Their answer after they raise both sides. Of an equation by an even power. Okay, so you guys good? You see where, now can you see the error? Now you're not gonna make that error? I can only hope, right?
I'll try not to.
Maybe you'll remember this conversation.
I really hope I do.
I do
And then I
too.
won't make the error.
Okay, so another question. What about write the following? 6 plus the square root of negative 28 all over 8 in a plus bi form. Okay, so basically, we just want to break this down. And so we want to pull out what we can from underneath the square root. And so let's first do that. Let's rewrite it. So we have 6 plus the square root. So I know that this is 4 times 7 is 28. So I'm going to write this as 4. There's a negative 1 in there, which I know is I, times negative 1 times 7. All over, oops, our denominator of 8. And so this is equal to 6 plus, well, if we pull out the square root of 4, that's a 2. Pull out the square root of negative 1, that is I. And we're left with a 7 underneath the square root, all over 8. So in order to be an a plus bi form, this cannot be one fraction. And so we need to break this down. I can either break it down now and then reduce, or I can pull out a common factor and then reduce later. Let's pull out the common factor now. It would usually be easier the other way, but I think just so that you're used to doing this, if this was your answer and you had to put it onto MyMathLab and it didn't say a plus bi form, you could leave it like this, except that it would have had to been simplified. So notice that 6 plus 2i root 7, 6 and 2 have a 2 in common. So we can factor a 2 out of the 2 groupings in the numerator. So we'd be left with a 3 when we pull the 2 out of the 6. Plus, if we pull 2 out of 2i root 7, you're left with I root 7. All over 8. But notice that 2 and 8, I can simplify this now because it's strictly multiplication between that 2 and the parentheses. And so 2 goes into itself once and 2 goes into 8 4 times. So we want to break this down as 2 separate fractions. And so I can break this down as 3 all over the 4 plus a plus bi form. So I'm going to just put the I after the fraction. So this is root 7 all over the denominator of 4. And I'm just going to put the I here.
Okay, if we put the I in the front, well, that's wrong.
No, I'm okay with the I in the front, but normally you'll see the I behind like it is right here. So that's why I did it. But I won't mark it wrong. I would knock off a point if you didn't reduce it. You could have, like I said, you could have first rewritten it as 2 fractions, 6/8 plus 2i root 7 all over 8. Here, 6 over 8, 2 goes into both. So 3/4 plus 2 goes into 2 and 8. So this would have been I root 7 over 4. So either way, you would have gotten the same results. And right there, I didn't pull the I out. Kind of left it like what you were talking about. So what if it says same question, you want to put your answer in a plus bi form, and but this time you have in parentheses 10 minus the square root of negative 18, end your parentheses, minus another parentheses 9 plus 5 square root of negative 8 in that parentheses. Just gonna make sure that goes way down there because I don't want it. Okay, so we want to pull out what you can from underneath the square root. And then I also see the negative in front of the second parentheses. And so we're going to have to distribute the negative to every single term inside the second parentheses. And so let's bring down the 10. There's only a 1 outside that parenthesis, so I really don't need it. Minus the square root. So breaking this down, 18 can be broken down as 9 times 2. So 9 times negative 1 times 2. Minus, distributing that negative, I get minus 9. Minus 5. And let's break down the square root of negative 8. So this is like 4 times negative 1 times 2. So we get 10 minus, so pull out what you can. So square root of 9 is 3. Square root of negative 1 is I. And we're left with a root 2. Minus 9 minus 5 times, so pull out what you can. Square root of 4 is 2. Square root of negative 1 is I. And then we're left with square root of 2. So we want to combine like terms. Notice here you have a 10 minus a 9, and those are like. So 10 minus 9 is 1. And then I notice I have a, well, let's just bring it down. So this is minus 3i root 2. And then right here, this is minus 5 times 2. So this is minus 10i root 2. So looking at this, I notice these are both like terms because they both have an I outside of the radical. They both have a square root of 2, same index. And so we can combine like terms. So a negative 3i root 2 minus a 10i root 2. So negative 3 minus 10. So this is 1 minus 13i root 2. And so it's an a plus bi form. You might write the I after the root 2, but again, in this case, the I, you have to just make sure that it's shown that it's not underneath the radical. Oops. Okay, so you're given the following: x squared plus, you have some blank in here, plus 36. And you're asked, find what you can add to make this a perfect square. Okay, so we want this to be a perfect square. We need to figure out what we can add in here. And there's actually a couple things that we can add to make that a perfect square. Any
Did
ideas?
you add 12?
Okay, so 12. Let me change it.
Because 6 times 6 equals 36, and 6 plus 6 equals 12.
Okay, you are almost there. But you're missing one little piece. I think you said it, Erica.
Don't you have to square? Nah.
So normally we were looking for what we were adding here. So we're kind of doing it kind of backwards. So we were looking at what we were going to add here. And so we divided this by 2, which would give us 6. And then we multiplied it by itself. 6 times 6 is 36. The thing is that this is missing the x.
Oh.
Because if I didn't have that x there, then I could combine 12 plus 36, which is 48, and that doesn't make the perfect square. So actually, it just needed that x. You were just so close. And so notice that this is the same thing. Sorry. So we get x squared plus 12x plus 36 is the same thing as x plus 6 quantity squared. Okay, it might say find 2 things. So there's one other thing that would make this a perfect square. Any ideas? Maybe you got that, maybe you didn't. Negative 12x. Okay, so we had done 12x. And
Negative and a negative, it's a positive.
yeah, so if we divide negative 12 by 2, we get negative 6, but negative 6 times negative 6 gives us this 36. Or negative 6 minus 6 equals negative 12. But we needed that x piece in there too. And so x squared minus 12x plus 36. If you rewrote this as a perfect square, it would be x minus 6 quantity squared. Okay. Just want to make sure you have it before I move on. What if you had 5x squared plus the square root of 2, and then outside of the square root is times x, minus 1 equals 0, and it says use the quadratic formula. To solve. Okay, quadratic formula. That's the negative boy couldn't decide if to go to the radical party or b squared minus 4. Who's out on 4 awesome chicks, all to be over at 2 a.m. And so now we gotta look at who is our awesome person, who's our boy, and who is our chick. A is awesome is 5, so A is 5. B is equal to root 2. And C is equal to
-1.
right, -1. And so plug in, we get X is equal to negative B, so negative root 2. Couldn't decide, plus or minus the square root B, which is root 2 squared, minus 4 times A, which is 5, times C, which is -1, all over 2 times A, and A was 5.
The only one that carries the sign is the C, right?
They would all carry the sign, but the sign in front of the 5 is positive, so I don't have to write
Okay.
the plus there. Same thing with the root 2. But if this had been negative root 2, I'd put it here, but that actually wouldn't affect it, but it does affect it out here, because squaring it would give me the same thing as if it had been positive. So just simplify it. So you have negative root 2 plus or minus the square root. Well, if you square a radical, it just isolates and gives you the radicand, which is 2. So we're just left with that 2. Minus 4 times 5, that's negative 20 times -1. Negative 20 times -1 is positive 20. All over 2 times 5, which is 10. So this is equal to negative root 2 plus or minus square root of 22 all over 10. So I can't add or subtract these radicals because they don't have identical numbers underneath. And so I can leave it in this form. I can't cancel any of the numbers because the 2's are underneath the radical and the 10 is not. Even if the 10 was underneath the radical, I couldn't. And so that's our solution. Okay, one more. Type. I saw that might be different than what you've seen. What if it asked you to write a polynomial with the 3 solutions -2, 4, and 3. Okay, so kind of this is going backwards to what we were doing. We were finding, basically solving equations, solving polynomials for solutions. And when we were solving polynomials, one of the ways that we did that was factoring it. And so if we could get the set equal to 0 and we could get it factored, then we could set each factor equal to 0 and find those solutions. So we're basically working backwards. And so think of it this way. Think of it as x equals -2. That's a solution, right? X equals 4. That's a solution. And x equals 3. That's a solution. Well, let's set each one of these equal to 0. So basically, for the first equation, I would add 2 to both sides, right? And so if I add 2 to both sides, well, those aren't like terms. That's just x plus 2 is equal to 0. So to get x equal 4 set equal to 0, subtract 4 on both sides. Not like terms. So this is x minus 4 is equal to 0. Same idea for the third equation, subtract 3 on both sides, we get x minus 3 is equal to 0. So we're using the fact that these were solutions of the equation, then we know that the factors, if we multiplied them together, so x plus 2 all times the factor of x minus 4 all times the factor of x minus 3. Those are solutions if this equation was equal to 0. Okay, so we wanted to know the polynomial. So we just want to expand this out, and then we have the polynomial that would give us the 3 solutions of -4, 4, and 3. There's actually an infinite number of ones that would give us the same solution. If I had any constant out here, like 5, that still would give me the same solutions. If I put 6 out here, that still gives me the same solutions, or -8. So there are an infinite number of solutions, but this is one of them. And that's the easiest one. Okay, so let me just multiply that out. X plus 2 times x minus 4. So let's just multiply 2 of them out first, and then we'll bring down the x minus 3 and then distribute. So x times x, this gives us x squared. X times -4 is minus 4x. 2 times x, so plus 2x. And 2 times -4 gives us -8. So we're going to do that all times x minus 3. This was equal to 0. So before I distribute, I'm going to combine like terms inside my parentheses. And so I have a -4x plus a 2x. So I have x squared minus 2x minus 8 all times x minus 3 equals 0. So distribute. So I have x times x is x cubed. X times -3, so minus 3x squared. Sorry, that was x squared. -2x times x, so that's a -2x squared. -2x times -3, so that's a plus 6x. So now distribute the -8. -8 times x is -8x, and -8 times -3 is plus 24, which is equal to 0. Almost there. Combine any like terms, and we're done. And so there's only one term with the x cubed. So we have x cubed, and then we have a -3x squared minus a 2x squared. So this gives me a minus 5x squared. We have a positive 6x minus an 8x, so this is minus 2x. And then we have the plus 24 equals 0. Okay, so instead of us going backwards where we normally do, where we're given an equation and say solve for this equation, and a lot of times we would just factor, and when we could do that, it gave us the solutions and wanted us to find the equation or an equation with those solutions. Okay, so that is pretty much all the types of problems that are kind of different or worded differently that you might see on the test on Wednesday. Is there any questions or any types of things that you guys want to go over? Just, you guys just do your best. You're going to do fine.
How many problems?
So
3? Okay, thank you.
I know I'm going to just cause you more anxiety if I tell you what I have in there right now, but I don't know if what I have in there is exactly what my test is going to be, if I'm going to delete stuff, if I'm going to add stuff. Right now, it tells me, or right now there's 38 questions,
Ow.
but it tells me that estimated time should be 28 minutes to complete. So, because they have the questions where they've taken where students use that question to complete it. They've found data on how long it takes a question for students to normally complete it. They average it. But, you know, that could be skewed if someone leaves their computer on and walks away from the computer for a long time, you know, because I've seen problems where it said that it took like an hour or something, which there's no. But I think they realized too that those things, if you guys had statistics, or when you use statistics or see it, you'll talk about outliers. So things that are way outside of what your normal data looks like. And so a lot of times you don't look at those outliers when you're looking at averages.
Okay.
Any questions? Other questions besides how many questions? So I'm not quite sure on that. Yeah. This is all new for all of us. But you guys, one of the bonus things is that you have been using my math lab this whole time. And so it's not going to be unfamiliar when you go in to take the test. So it'll be something that it's not like a new program that you're trying to relearn or something. And then also I'm going to see the question. It's going to be kind of difficult to grade because all the questions are going to be scrambled and all your numbers are going to be different too. So it's not like one key for me to make.
My math lab doesn't correct it for you?
So my math lab will correct it for me, but the thing is I'm going to have to look at your work, and because if you get something wrong, I want to go back and give you partial credit.
Okay.
And then I might like go through and say, okay, well, I think number 5 on my math lab, that's like a 5-point question, where number 1 on my math lab is worth like a 2-point question maybe.
Oh,
and so that way I can, you know, do partial credit and stuff like that. So that might not show exactly on my math lab what each question is weighted.
Okay.
And just to let you know, my math lab, it's not that always correct. I have a question where like I need to email you on that, and I'm kind of upset because it marked it wrong and it shouldn't be wrong.
Okay, so send that to me and I'll look at it, because a lot of times students think that it was right and it shouldn't have been wrong. I don't know. But I'll find some. Usually the cases I find the error, but if it's the same correct answer, maybe not in the right form or something, I'll give you the credit.
I've had that happen to me where I was like, no way am I wrong. This is totally right. And then I realized there's a small little thing. I'm like, F this. Okay.
I double, tripled, and I with different people too, and it was the same thing, and we still. So I mean, if it is wrong, then shame on all of us.
No, but it's also really easy too when you're looking at somebody's work, like we were looking at that student's work, not to be able to see the error, because you're walking through it and you're like, oh yeah, that looks correct. That's right reasoning, you know. And I do that sometimes too when I'm grading your work, where I'm like, where is that error? You know, I know it's wrong because it's not the same answer, but it's like sometimes it's hard to figure out, you know, what was that little mistake you guys did.
Well, sometimes too, where I'll get the problem I did right, but it wasn't necessarily what like I'll mix up one number halfway through it and I'll finish it that way. So the answer will be right, but then I realize, oh crap, I shouldn't have, anyway, yeah. So, my math lab. Ooh.
Any other questions? Okay, so one other thing I wanted to share with you, which I don't.
Are you still recording?
I'm still recording. There is one other thing I want to share with you guys. So the day of the exam, I'm still going to hold lecture. And it doesn't matter if anyone's there or not there, but I'm going to hold lecture because we got to move ahead on material. And so you can come to lecture during the normal time, or you can watch the video later, like some students are doing.
If we are not in class on that Wednesday, are we gonna get docked for that? I just don't wanna,
No, don't worry about it. If you wanna just worry about the test on Wednesday and not worry about it, but you're gonna have to within between Wednesday and Sunday evening, you're gonna wanna watch it and take your notes. And so you also be able to do the homework.
Okay,
Okay.
thank you.
Yeah, no worries. The other thing is, because I'm doing a teaching community and leading it, we are doing observations right now where we're observing other instructors or places on campus. Well, that's not really happening. But I thought it would be a cool thing to watch other faculty members that I know at different community colleges around the state. And one of the instructors is teaching online during my office hours on Wednesday. So if possible, I want to not have my office hours on Wednesday. But if you want to meet with me anytime on Wednesday when I'm not teaching my normal class time and I'm not in that observing somebody, we can set up a time. Is that okay?
Sounds good.
Okay. Okay. I'm going to let you guys go unless there's any other questions.
Thank you.
Have a good day.
I'll be available from 1 to 2 for office hours today if you guys need help, okay? And then I have office hours tomorrow if you guys need any help.
Good luck,
And
guys.
Good luck, Chelsea.
Oh, thanks.
good luck. I'm praying for all of you. I'm really praying everybody is doing a great job. And you
You
guys-
took 28 minutes for 38 questions. Woo!
This should be interesting.
No, the other thing is I will sit down and I will take the test too. And that's what I normally do. And I take what I do and I try to multiply it by 3 or 4 times that for what a student should take a student to do. So I'll look at that too when I look at how long my math lab says.
Some of us need more time.
More than 3 or 4 times what I do.
I'm a slow learner. It takes a minute to process the problems through my head.
I know.
But
You guys practice, practice, practice. That's all I can say. It makes you get better and hopefully become perfect. I'm not even perfect. Look at all the errors I make just on little little things like thinking ahead or I don't know. Okay.
Well,
all right.
Thank you.
Okay.
Have a good day.
You too.
Bye.
Bye.
Practicing. Bye.
Bye.